Hi, I'm your tutor Andy, and for today's video, we are going to talk about acceleration. Throughout this chapter, we will use the following terms: time, displacement, velocity, and acceleration. Recall that each of these terms has a designated variable and SI unit of measurement as follows. Time, t, measured in seconds. Displacement, delta d, measured in meters. Velocity, v, measured in meters per second. And acceleration, a, measured in meters per second squared. Also note the following. Delta means change in. The subscript naught refers to an initial value. The subscript f refers to final value, and a bar over a symbol means average. Acceleration is the change in velocity divided by a period of time during which the change occurs. It is also given by final velocity minus initial velocity all over final time minus initial time. The SI units of velocity are meters per second, and the SI units for time are s, or seconds. So the SI units for acceleration are meters per second squared. Average acceleration is distinguished from instantaneous acceleration, which is acceleration at a specific instant in time. Note that the average acceleration can be positive, negative, or zero because it is a vector quantity. A negative acceleration is simply an acceleration in the negative direction. For now, let us assume that motion to the right along the x-axis is positive and the motion to the left is negative. Let's try to answer this example. A subway train accelerates from rest to 30 kilometers per hour in 20 seconds. What is the average acceleration during that time interval? So this problem involves 4 steps. First is we need to convert the units to meters and seconds. Second is we need to determine the change in velocity. Next, to determine the change in time. And lastly, to use these values to calculate the average acceleration. In converting the units, our goal here is to convert 30 kilometers per hour to meters per second. So we put our given value on the first column, 30 kilometers, and hour at the divisor. Next, in order to cancel out kilometers, we must also put kilometers on this cell. Since our goal is to meters, we put m on this cell. Same goes for hour and seconds. Next step is we have to look for equivalent values on these units. In this case, we know that 1 kilometer is equal to 1,000 meters and 1 hour is equal to 3,600 seconds. Now that we can cancel out kilometer per hour, we are now left with meters per second. When we input these values in our calculator, this will give us 8.333. When the problem states that the train starts from rest, you can write down that the initial velocity is 0 meters per second. Final velocity is equal to 8.333 meters per second. And change in time is 20 seconds. Next is we have to calculate the change in velocity, where the plus sign means the change in velocity is to the right. We know change in time, so all we had to do is insert the known values into the formula for average acceleration. And we will get positive 0.417 meters per second squared. The plus sign in the answer means that acceleration is to the right. This is a reasonable conclusion because the train starts from rest and ends up with a velocity directed to the right. So acceleration is in the same direction as the change in velocity, as it should be. Now, suppose that at the end of its trip, the train slows to a stop in 8 seconds from a speed of 30 kilometers per hour. What is its average acceleration during this time? As in the previous example, we must find the change in velocity and change in time, then solve for acceleration. So first we have to identify the knowns. Our initial velocity is 30 kilometers per hour. Final velocity is 0. And change in time is 8 seconds. Next is to convert the units. So from the first problem, we know that 30 kilometers per hour is equal to 8.333 meters per second. Next is we have to calculate change in velocity. Where the minus sign means that the change in velocity points to the left. We know that change in time is 8 seconds, so all we have to do is insert the known values into the equation for average acceleration. The minus sign indicates that acceleration is to the left. This is reasonable because the train initially has a positive velocity in this problem, and a negative acceleration would reduce the velocity. Again, acceleration is in the same direction as the change in velocity, which is negative in this case. This acceleration can be called deceleration because it has a direction opposite to the velocity. I hope you learned something today. See you on the next video.